Hello students, we are going to start today the heat and thermodynamics portion, and in that portion we will try to understand what is heat and what is thermodynamics. So our discussion is see what I would like to tell you. Heat you have read in junior classes also, but here this chapter is free from the load of mechanics. With less knowledge of mechanics also you can understand this heat chapter in a better way. Only thing is required that you have to concentrate. I am putting my full effort and you also have to prove your hard labor. So this thermodynamics portion is present in both physics and chemistry. In physics and chemistry it is present, and you should understand that the matter remains the same. Whether we are talking about physics or whether we are talking about chemistry, the matter remains the same. Only thing is that you have to keep that there are certain things that we teach only in physics, and in that it is your heat engine. Heat engine we discuss only in physics, not in chemistry. Then refrigerator, that is heat pump. This we only discuss in physics, not in chemistry. Whereas there are certain things that are being taught in chemistry only, and those things are enthalpy, entropy. These are the things that are being taught in chemistry only. We will not discuss it in physics. So in heat and thermodynamics, first we will have to understand the concept of heat. So in order to understand the concept of heat, what is required? You already know that it is the form of energy, but it is that form of energy which flows due to temperature difference. If temperature difference is there, then only you can understand that heat energy flows. So basically what I mean to say that heat has got the unit joule and work has also got the unit joule, but this is mechanical energy. And heat is basically due to temperature difference. The flow of energy is called heat. So heat flow, what is the cause? Cause is your temperature difference. Temperature difference is the cause of your heat flow. So heat is a form of energy which flows due to temperature difference, and it also tells the thermal state of matter. It also tells, so this is the basic definition of heat. What I would like to tell you, temperature difference is the cause. Basic energy is internal energy. Basic energy is internal energy. And what is internal energy? Internal energy is the basic energy. Internal energy is the basic energy when due to motion there is kinetic energy, and due to position there is potential energy, and the sum of potential energy and kinetic energy gives you the internal energy. and at the same time heat is that part of internal energy which flows due to temperature difference. So the cause of heat flow is basically your temperature difference, and heat is that part of internal energy which flows due to temperature difference. So temperature difference is the cause of heat flow. There is a statement that body has internal energy and body has heat. In this statement is true. This statement is true, whereas this statement is false. Why? The heat is basically depending on the flow of internal energy, that is heat is basically depending on the situation, that whether the surrounding has a temperature difference or not. So every body possesses internal energy, this is a true statement, but body has heat, this is not the correct statement. Now we will talk about temperature. Temperature is the concept that is directly derived from Jiroth Law of Thermodynamics. You might have heard about first law, second law. In the similar way, there is Jiroth Law of Thermodynamics, which gives the concept of temperature. And what is that Jiroth Law? There is a term, thermal equilibrium. Thermal equilibrium means same temperature. Thermal equilibrium means same temperature. What does it mean? I mean to say that if two bodies, suppose A and B, have the same temperature, then we call that they are in thermal equilibrium. If the two bodies A and B have same temperature, that means they are in thermal equilibrium. Now, what the Jiroth Law says, according to Jiroth Law, body A is in thermal equilibrium with body C. This is in thermal equilibrium. And body B is in thermal equilibrium with body C. Then, according to Jiroth Law, body A is in thermal equilibrium with B. This tells the explanation of Jiroth Law. Body A is in thermal equilibrium of B, B is in thermal equilibrium of C, then A and B are in thermal equilibrium. That means temperature of A is equals to temperature of C, temperature of B is equals to temperature of C, then temperature of A and B are also equal. So this is the concept of Jiroth Law of Thermodynamics, and this defines the temperature. Temperature concept comes from the Jiroth Law of Thermodynamics. Now, one more thing I would like to tell you. Temperature is a scalar quantity. Temperature is a scalar quantity. It is measured in unit Kelvin. It is measured in unit Kelvin. Temperature is a scalar quantity and it is measured in unit Kelvin. Lowest possible temperature is 0 K. This is not OK. This is not OK. This is 0 K. In K, 0 degree K. This is not correct. This is not we write. We cannot write 0 degree K. It is 0 K. This is the lowest possible temperature. One thing I would like to tell you, at 0 K, that is the lowest possible temperature, the behavior of substance changes. And you might have heard about superconductor. In superconductor, the resistance nearly becomes zero and behavior of conductor changes. In lab we have achieved up to 3 to 4 K temperature, and the study of various less temperature or at this temperature behavior, this is known as cryogenics. This portion of a study at very low temperature is known as cryogenics, and very high temperature study is known as pyrometry. Very high temperature, and we have been able in achieving about 10 to the power 8 Kelvin. Upper limit is not there in higher temperature, but lower limit is there, that is 0 Kelvin. Now what I would like to tell you, I would like to tell you the temperature scale. In temperature scale, basically there are 2 points. One is lower fixed point, one is upper fixed point. Lower fixed point, upper fixed point. Lower fixed point is basically a melting point of temperature. Melting point temperature of ice. That is your at 1 atmospheric pressure. This is lower fixed point. And upper fixed point is boiling point of water. Boiling point of water at the same 1 atmospheric pressure. This is the lower fixed point, and in degree centigrade scale, this is value is 0 degree centigrade, this is 100 degree centigrade, this is 32 degree Fahrenheit, this is 212 degree Fahrenheit. In Kelvin scale, it is 273, it is 373 Kelvin. That means ice melts at the temperature 0 degree centigrade or 32 degree Fahrenheit or 273 Kelvin, and water boils, pure water boils at normal temperature, at a normal atmospheric pressure, 1 atmospheric, at 100 degree centigrade, 212 degree Fahrenheit and 373 Kelvin. What I mean to say here, I mean to say here that in conversion we have to use one formula. What is that? Temperature X minus lower fixed point by upper fixed point minus lower fixed point is equals to constant. For any scale it is constant. Temperature minus lower fixed point by upper fixed point minus lower fixed point is constant for any scale. And you should understand this is also called upper fixed point minus lower fixed point is also called fundamental difference. On this basis we can do conversion, any conversion we can do very easily. Very easily we can do any conversion. Any conversion we can do very easily. Now we are getting a general formula of this type, that if you want to get a formula for conversion of temperature in different scale, we can get in this way. In centigrade, C minus lower fixed point by upper fixed point minus lower fixed point must be. In Fahrenheit, minus lower fixed point minus lower fixed point. In Fahrenheit, in Kelvin, in any scale x minus lower fixed point by this is the way the relation exists. And if we want to talk in terms of temperature difference, then it should be delta C by 100 must be equals to delta F by 180 must be equals to delta K by 100 is equals to delta X by fundamental difference. This is the thing that you should understand. This is the thing you should understand. Now any conversion can be done with this help, and you know thermometer, the device, the simple things are there that you already have read in your junior classes, that thermometer is a device which is used to measure temperature. Different types of thermometers are there, but basically this relation you all should remember in a very proper way for understanding and solving the questions based on thermometry. And this is fundamental question that you have already read in your junior classes also. Now we will try to do few questions based on this concept that I have dealt with you. On this fundamental concept I would like to discuss few questions. A basic fundamental question that you already know: at what temperature the reading in Fahrenheit scale and is same. Suppose this is an example that I am taking. Basic fundamental question, you already know the answer. I know this is very simple. So fundamental reading in degree Fahrenheit, I am considering that temperature as x, and in degree centigrade I am considering that temperature as x, because same is there, so value will remain same. So x minus 0 by 100 is equals to x minus 32 by 180. 0 0 will cancel. X by 10, x minus 32 by 18, 18x, 10x, 320, 8x is equals to minus 320, so x is equals to minus 40. What does it mean? It means that minus 40 degree centigrade is equals to minus 40 degree Fahrenheit. This is the meaning of this statement. The very basic fundamental question. The very basic fundamental question. Second example we can take the temperature. The second question is the temperature of a body changes from 30 degree to 60 degree. Find the temperature difference in degree Fahrenheit and Kelvin scale. In order to get this relation, what I have said, delta T is equals to 60 minus 30, that is 30 degree C. What I have said, for Fahrenheit, delta T by 100 is equals to delta T in Fahrenheit by how much? 180. So this will cancel, and this value you are getting how much? 30. So 30 by 10 delta T in Fahrenheit by 18. So delta T in Fahrenheit is how much? 54 degree Fahrenheit. So 30 degree change in degree centigrade is equals to 54 degree change in Fahrenheit. And as you have seen that in Kelvin scale the difference remains the same, so delta T in Kelvin that remains 30 Kelvin. So in Kelvin scale it remains the same, whereas in Fahrenheit scale it changes. Why it changes? Because you try to understand. Here the degree centigrade is there 0 and 100 degree centigrade, and in Fahrenheit what you are getting? 32 and 212. So it is 180. So what does it mean? It means that 100 degree centigrade change is equivalent to 180 degree Fahrenheit change. So if you talk about 1 degree change, you will get 1.8 degree in Fahrenheit, and if you will take the 30 degree that we have get 30 degree change, we will get 30 into 1.8, that is. So by this also you can understand that the answer remains the same, that whether it is 30 degree change in centigrade is equivalent to 54 degree change, whether you can use the formula or whether you can use the fundamental principle, both you will be getting the same. Let us discuss few entrance questions that are being asked in medical and engineering entrance examination as the objective questions. Let us try to understand. The first question is here that tells you that in a mercury thermometer the ice point is marked at 10 degrees C, whereas the steam point is marked 40 degrees C. Temperature, what this thermometer read? In this question you see that here is the lower fixed point, here is the upper fixed point, here is the upper fixed point. So three data are there, and you have to tell what is the value of 40 degrees C on this thermometer. Naturally we know and we understand that in centigrade 40 degree centigrade minus 0 by 100 fundamental difference must be equals to temperature T on that scale, lower fixed point is 10 by upper minus lower. This is the relation that we can understand from this question. So this T is the temperature of the thermometer. So what we are getting? We are getting, this will give T minus 10 by 120. So finally we can cancel it. 4 by 10 must be equals to T minus 10 by 120. This will cancel. So T is equals to 48 plus 10, that is 58 degree. So 58 degree is the correct option. This also we can understand. Now let us do the next question. The second question, as I have told you, the pyrometer is used to measure A, high temperature, B, low temperature, C, specific heat, D, latent heat. As in the discussion of theory, I have said that pyrometry is the study of very high temperature. So naturally it is an instrument. So this instrument is used to measure high temperature. So pyrometer is an instrument used to measure very high temperature. For example, the measurement of sun, temperature of sun. So temperature of sun is measured with the help of pyrometer because it is very high temperature that is being used by the instrument pyrometer to measure. Now try to understand This question, 40 degrees centigrade in Fahrenheit scale is equals to. This type of question we have already done. 40 degrees centigrade is there. 40 minus 0 by 100. Temperature T in Fahrenheit minus 32 by 180. This will cancel. This will cancel. 72 is equals to T minus 32. So T should be equals to 72 plus 32. So 40 degree centigrade is equals to 104 degree Fahrenheit. And you can understand very well that this is the fundamental relation that we have discussed in the theory section earlier. Now see, in this question, on a new scale of temperature which is linear and called W scale. Name of this scale is W scale. The freezing point and the boiling point of water are 39 W and 239 W respectively. What will be the temperature on the new scale corresponding to a temperature of 39 degrees centigrade on the Celsius scale? So on Celsius scale temperature is this, and you have to find on W scale that what will be the temperature. Now in order to solve this question, what I would like to tell you, let us try to understand that here the relation exists the same that we have earlier discussed. You see, degree centigrade 39 minus 0 by 100. Centigrade scale temperature minus lower fixed point by difference must be equals to temperature T minus lower fixed point is 39 by difference 239 minus 39, and this is giving you 39 by 100 T minus 39 by 200. 0 0 will cancel. 78 T minus 39. So T 78 plus 39. So 117 W. This should be your right answer. See it carefully. This is the lower fixed point on the W scale. This is the upper fixed point on the W scale. This is the lower fixed point. This is the 39. That is the temperature on the centigrade scale, and lower fixed point is 0 divided by difference, fundamental difference, and ultimately we are getting T. That T must be equals to 117 W. So on new scale W, this 39 degree centigrade is equivalent to 117 degree W. So this should be understood carefully. Now in this question, two temperature scales A and B. One temperature scale is A and another temperature scale is B, are related by this relation. This is the relation that exists between A and B. At what temperature the two scales have the same reading? Let us take that temperature is T. So according to that relation, according to question, what we can understand, T minus 42 by 110 must be equals to T minus 72 by 220, because on both scale the temperature is same. So we can get 2T minus 84 must be equals to T minus 72. This tells 2T must be equals to 84 minus 72, and this is giving you 12. So 2T minus T is equals to 2T minus T is equals to 84 minus 72, and we are getting 12. So the value of T that we have got is 12. So this should be our right answer. Now one note you should understand and remember very carefully, because mercury thermometer is the most common thermometer. The boiling point of mercury is 367 degrees centigrade. But mercury thermometer are made such that they can measure temperature up to 500 degrees centigrade. Naturally, some sort of modification, some sort of change is required. In that change, what we do? This is done by filling nitrogen at high pressure above the mercury column. This is very important fact that is frequently asked in entrance examination. That also, this information you should keep in your mind. With this much amount of discussion of questions based on thermometry and the discussion of heat and thermometry, I hope that you have understood the matter and it will clarify your concept somehow in a better way, and this will help you. If you prepare up to this mark, then I hope any question that will be asked from this section, whether it is the board examination or it is the entrance examination, you will feel highly confident and comfortable in facing and answering the questions that can be asked on this topic. Thank you. Have a nice day.